Trick to remember P-block reactions. I will teach you the common tricks to learn P-block reactions. First of all, we will learn important reactions of nitric acid. We know that nitric acid is a good oxidizing agent. The first type of nitric acid reaction is reactions with more reactive metals like iron, zinc, tin, etc. Here, there are three important rules to crack these reactions. Firstly, if a reactive metal reacts with very dilute HNO3, ammonium nitrate is produced. Secondly, if a reactive metal reacts with dilute HNO3, nitrous oxide is produced. Thirdly, if a reactive metal reacts with concentrated HNO3, nitrogen dioxide is produced. For example, consider a reactive metal like iron. Let iron reacts with very dilute HNO3. Secondly, iron reacts with dilute HNO3. Thirdly, iron reacts with concentrated HNO3. Now listen carefully. Iron nitrate and water is produced in these all three reactions. Let me repeat it. Iron nitrate and water is produced in these all three reactions. Thus, iron nitrate and water is produced in the first reaction. Iron nitrate and water is produced in the second reaction. Also, iron nitrate and water is produced in the third reaction. According to the rules, if very dilute nitric acid reacts with iron, ammonium nitrate is produced. So here, ammonium nitrate is produced. Secondly, if dilute nitric acid reacts with iron, nitrous oxide is produced. So here, nitrous oxide is produced. Lastly, if concentrated nitric acid reacts with iron, nitrogen dioxide is produced. Thus, these are the three important reactions of iron with nitric acid. Now consider the second reactive metal like zinc. Let zinc reacts with very dilute nitric acid. Secondly, zinc reacts with dilute nitric acid. Thirdly, zinc reacts with concentrated nitric acid. As usual, in all these three reactions, zinc nitrate and water is produced. Thus, in the first reaction, zinc nitrate and water is produced. In the second reaction, zinc nitrate and water is produced. In the third reaction, zinc nitrate and water is produced. Now, according to the rules, in the first reaction, ammonium nitrate is produced. In the second reaction, nitrous oxide is produced, while in the third reaction, nitrogen dioxide is produced. Thus, these are the three important reactions of zinc with nitric acid. Now consider the third reactive metal like tin. Let tin reacts with very dilute nitric acid. Secondly, tin reacts with dilute nitric acid. Thirdly, tin reacts with concentrated nitric acid. Now listen carefully. We do not study the reaction of tin with very dilute nitric acid at this stage, while the second and the third reactions are both exception cases. Now listen carefully. When tin reacts with dilute nitric acid, as usual, tin nitrate is produced and water is also produced. Remember that we also call it stannic nitrate. On the other hand, when tin reacts with concentrated nitric acid, instead of tin nitrate, H2SNO3 is produced and water is also produced. Remember that we call this important compound as metastannic acid. Now what about the third product of these two reactions? Well, according to the given rules, you can say that in case of dilute HNO3, it is nitrous oxide, And in case of concentrated HNO3, it is nitrogen dioxide. But they are wrong. Here, you have to remember this simple trick. I say, this is the first reaction and this is the last reaction. In case of first reaction, the first rule has ammonium nitrate. So I write here ammonium nitrate. In case of last reaction, the last rule has nitrogen dioxide. So I write here nitrogen dioxide. So everything is just boom. Thus these are the two important and exception cases of tin reactions with nitric acid. Now we will learn type 2 reactions of nitric acid with less reactive metals like copper, silver and mercury. There are two important rules to crack these reactions. Firstly, if dilute nitric acid reacts with less reactive metals, nitric oxide gas or nitrogen monoxide gas is produced. Secondly, if concentrated nitric acid reacts with less reactive metals, nitrogen dioxide gas is produced. For example, consider a less reactive metal like copper. Let copper reacts with dilute nitric acid and copper reacts with concentrated nitric acid. As usual, in both reactions, copper nitrate and water are produced. I write copper nitrate plus water and copper nitrate plus water. According to the rules, if copper reacts with dilute nitric acid, nitric oxide is formed. I write nitric oxide. Secondly, if copper reacts with concentrated nitric acid, nitrogen dioxide gas is produced. I write nitrogen dioxide gas. These are the two important reactions of copper with nitric acid. Now consider another less reactive metal like silver. Let silver reacts with dilute nitric acid and silver reacts with concentrated nitric acid. As usual, I get silver nitrate plus water and silver nitrate plus water. According to the rule, when silver reacts with dilute nitric acid, nitric oxide gas is produced. Secondly, when silver reacts with concentrated nitric acid, nitrogen dioxide gas is produced. Thus, these are the two important reactions of silver with nitric acid. Lastly, consider another less reactive metal like mercury. Let mercury reacts with dilute nitric acid and mercury reacts with concentrated nitric acid. Remember that this first reaction is exception case. I leave it for a moment. In the second reaction, mercury nitrate plus water is produced. We call this compound as mercurous nitrate. According to the rule, if concentrated HNO3 reacts with mercury, nitrogen dioxide gas is produced. Now in the first case, instead of HgNO3, Hg2NO32 is produced. We call it mercurous nitrate. Also, water is produced. According to the rule, if dilute nitric acid reacts with silver, nitric oxide is produced. Hence, these are the two important reactions of mercury with nitric acid. Therefore, using these simple tricks, we can easily learn all important reactions of nitric acid. Now we will learn important reactions of heating of ammonium salts. Let's consider ammonium nitrite, ammonium nitrate, and ammonium dichromate. What would be the product if they are heated? Well, the easy and common trick is to remove maximum water molecules from the given salts. Let me repeat it. The easy and common trick is to remove maximum water molecules from the given salts. For example, in case of ammonium nitrite, there are 2 nitrogen, 4 hydrogen and 2 oxygen. I can remove 2 water molecules from it. I write here 2H2O. I cancel 4 hydrogen atoms and 2 oxygen atoms. Now 2 nitrogen atoms are remaining. I write here N2 gas. I also cancel 2 nitrogen atoms. Thus the products of heating ammonium nitrite is nitrogen gas and 2 molecules of water. Secondly, in case of ammonium nitrate, there are 2 nitrogen, 4 hydrogen and 3 oxygen. I can remove 2 water molecules from it. I write 2 water molecules. I cancel the 4 hydrogen atoms. Out of 3 oxygen atoms, 2 oxygen atoms are used and 2 molecules of water. 1 oxygen is remaining. Here there are 2 nitrogen atoms and this 1 atom of oxygen combined together to form N2O or nitrous oxide gas. Thus the product of heating ammonium nitrate is nitrous oxide gas and 2 molecules of water. In case of ammonium dichromate, there are 2 nitrogen, 8 hydrogen, 2 chromium and 7 oxygen. Out of 8 hydrogen and 7 oxygen atoms, I can remove 4 molecules of water. I write here 4H2O. I cancel 8 hydrogen atoms. I also cancel 4 oxygen atoms and 3 atoms of oxygen are remaining. Now 2 chromium atoms and 3 oxygen atoms combine together to form Cr2O3 or chromium oxide. These 2 nitrogen atoms combine together to form nitrogen gas. Thus the products of heating of ammonium dichromate are nitrogen gas, chromium oxide and 4 water molecules. Now consider ammonium carbonate and ammonium chloride. Pause the video and try to find their products. Well, it is super easy. We can see that in ammonium carbonate, there are 2 nitrogen, 8 hydrogen, 1 carbon and 3 oxygen. We know that heating carbonate gives carbon dioxide gas. Here, 1 atom of carbon and 2 atoms of oxygen are combined together to form carbon dioxide gas. I cancel 1 carbon and out of 3 oxygen, 1 oxygen is remaining. Secondly, out of 8 hydrogen atoms, 2 hydrogen atoms are remaining. Here, these 2 hydrogen atoms combine with 1 oxygen atom to form 1 molecule of water. Now 6 hydrogen atoms and 2 nitrogen atoms are remaining. They combine together to form 2 NH3 molecules. Thus the product of heating ammonium carbonates are 2 ammonia molecules, water molecule and carbon dioxide gas. While in case of ammonium chloride, there are 1 nitrogen, 4 hydrogen and 1 chlorine atom. There is no oxygen atom, hence no water molecule is produced. Here, 1 hydrogen atom and chlorine atom combine together to form HCl. The remaining nitrogen atom and 3 hydrogen atoms combine together to form NH3. Thus the products of heating ammonium chloride are ammonia and HCl. Here you must learn 2 important reactions in which pure nitrogen gas is produced. The first one is barium azide and the second one is sodium azide. These 2 compounds are heated. What about their products? Well, it is super easy. We can see that in both the compounds there are N3 and N3. Thus in both the reactions 3 molecules of nitrogen gas are produced. Hence I write 3 nitrogen gas and 3 nitrogen gas. Remember that this nitrogen gas is 100% pure. In the first reaction, the metal is barium, while in the second reaction, the metal is sodium. We know that this is second reaction. I write here 2 and I also write here 2. Hence, this reaction is now balanced. Therefore, using this trick, we can easily produce pure nitrogen gas in these two reactions. Thus note it down. Now we will learn reactions of oxides of nitrogen. The first reaction is formation of nitrous oxide. Let's consider ammonium nitrate. We already learned in the previous slide that heating ammonium nitrate gives nitrous oxide gas and water. We can see that there are 2 nitrogen, 4 hydrogen and 3 oxygen. According to the trick, I remove maximum water molecules. I remove 2 water molecules. I write 2 H2O. Now 2 nitrogen atoms and 1 oxygen atoms are remaining. They combine together to form N2O or nitrous oxide. Thus remember that nitrous oxide gas and water molecule are produced if ammonium nitrate is heated. The second reaction is formation of nitric oxide and nitrogen dioxide. Remember that nitric oxide is also known as nitrogen monoxide. Now we take copper plus dilute HNO3. As a result, we get copper nitrate plus nitric oxide plus H2O. Also remember that when copper plus concentrated HNO3 reacts together, they form copper nitrate plus nitrogen dioxide and H2O. We will learn more about nitrogen dioxide gas later in this reaction. Thus remember that copper plus dilute nitric acid gives nitric oxide, while copper plus concentrated nitric acid gives nitrogen dioxide. The third reaction is formation of dinitrogen trioxide. Well, we take nitric oxide and nitrogen dioxide. When they react at very low temperature, they form dinitrogen trioxide. Remember that dinitrogen trioxide exists at very low temperature or negative temperature. Its color is pale yellow. At room temperature, it breaks down to nitric oxide and nitrogen dioxide. Thus remember that when nitric oxide and nitrogen dioxide react together at very low temperature, they form dinitrogen trioxide. The fourth reaction is formation of dinitrogen tetraoxide. We take nitrogen dioxide and nitrogen dioxide. When these both are cooled down, they form dinitrogen tetraoxide. Remember that the color of nitrogen dioxide is brown and the color of dinitrogen is colorless. Thus remember that when 2 molecules of nitrogen dioxide gas are cooled down, they convert to dinitrogen tetraoxide. The fifth reaction is formation of dinitrogen pentaoxide. We take P4O10 plus HNO3. When they react together, they form H3PO4 and N2O5. Hence note down these important reactions. The last reaction is formation of nitrogen dioxide. It is very important and I will teach you 3 different methods. We already learned the first method. We learned that when copper plus concentrated HNO3 react together, they form copper nitrate plus nitrogen dioxide gas plus water. Hence note down this first method. The second method of formation of nitrogen dioxide gas is heating of heavy metal nitrate. The rule for these reactions is very simple. When heavy metal nitrates are heated, we get metal oxide plus nitrogen dioxide gas plus oxygen gas. Let's consider heating of heavy metal nitrate like lead nitrate, mercury nitrate and silver nitrate. According to the rule, when lead nitrate is heated, we get lead oxide plus nitrogen dioxide plus oxygen gas. Similarly, when mercury nitrate is heated, we get mercury oxide plus nitrogen dioxide plus oxygen gas. Also, when we heat silver nitrate, we get silver oxide plus nitrogen dioxide plus oxygen gas. Thus remember that nitrogen dioxide gas is produced when heavy metal nitrates are heated. Also note down this exception case. In the first group, only lithium nitrate gives nitrogen dioxide gas. No other nitrate of first group elements gives nitrogen dioxide gas. I mean, lithium nitrate is heated. As a result, it produces lithium oxide plus nitrogen dioxide plus oxygen gas. Secondly, when magnesium nitrate is heated, we get magnesium oxide plus nitrogen dioxide gas plus oxygen gas. Thus remember that nitrogen dioxide gas is produced when heavy metal nitrates are heated. The third method of producing nitrogen gas is reacting nonmetals with concentrated nitric acid. The rules for these kinds of reactions is simple. Nonmetal plus concentrated nitric acid reacts together to form nonmetal acid plus nitrogen dioxide gas plus water. For example, consider sulfur plus concentrated HNO3, phosphorus plus concentrated HNO3, and carbon plus concentrated HNO3. According to the rule, when sulfur plus concentrated HNO3 reacts together, they form H2SO4 plus nitrogen dioxide gas plus water. When phosphorus plus concentrated HNO3 react together, they form H2PO4 plus nitrogen dioxide gas plus water. When carbon plus concentrated HNO3 react together, they form H2CO3 plus nitrogen dioxide gas plus water. Therefore, we say that when nonmetals react with concentrated HNO3, they produce nitrogen dioxide gas. If you want to remember all these reactions on your fingertips, write them on a neat sheet and pin the sheet on a wall. Try to revise them every day. It will help you a lot.